Okay, guys, today we're going to go ahead and keep going with our recursion and exponential growth and decay models. So in this first example, it says Derek is trying to save money for the down payment on a used car. His parents have said that in an effort to help him put aside money, they will pay him 10% interest on the money Derek accumulates each month. At the moment, he has saved $200. Suppose Derek does not add any money to the savings. Write a recursive rule and an explicit function rule that model the money Derek will accumulate with only the addition of the interest his parents pay. So what this is saying is that he has $200 saved. He's going to open an account, put the money into that savings account and just that $200, and he's not going to put anything else into it. Except for the interest that his parents give him. So if he has an extra $50 of his own money, he's not going to put it in. It's only the money that his parents give him, that 10% interest. So let's go ahead and kind of see what that would look like. So recursive rule. Let's see. Recursive. Okay, so we have the recursive rule. Remember, the recursive rule is the one where it's always going to go a sub n plus 1 is equal to a sub n. And since this one right here is an exponential growth equation, we're talking about a growth of 10%. So basically that means that right here, we're going to have this a sub n. This number right here needs to be that growth or decay rate that I'm going to have to multiply to the a sub n. So how much is this growing by? Well, it's growing by 10%. But if I take, for example, here, let me show you in the calculator. If I go ahead and I want to multiply, let's take $50. Okay, so if I have $50 and I want to multiply that by 10%. So I'm going to take that, multiply by 0.10. That's that 10%, right? Well, it gives me 5. That's because multiplying by 0.10 is getting me what is 10% of that 50. So what I need to do is I need to consider, okay, I've got that $50 times 1, oops, not times 10, times 1 plus the $50 times 0.10. You see, like that's going to take right here, this $50 times 1, that's that $50, and then I'm going to have that $50 times the 10% of that. So if I do that, now I have $55. So you see how this takes that $5, the 10%, and it adds it to the $50 that we started with. So this 1 right here, when we're talking about percentages, because here this 10% right here, that's 10%. So what is 1 when we're talking about percentages and it's written as a decimal? 0.10 is 10%. What is 1? That's 100%. So this is 110%. That's what this is saying. So what I have to do in order to do my recursive rule right here is I need to have that 1, because that's that 100%, 0.10. So this is 110%. And you can see that even if I did 1.10 times 100, that gets me 110%. Okay, so when you're writing something like this, you can't just write just the amount that it's changing by right here. We have to go, okay, if it's getting bigger, it's going to be 1 plus some number. If it's getting smaller, it's going to be 1 minus some number. So there's always going to be something to do with a 1 that's right within here. And then we're going to have that to the n. Oh, no, not that one. Sorry, because this is the recursive rule. So that's what I have right here. So I just have the next term in my sequence is taking the term before it and multiplying it by 1.10. So that's what I've got there. And then I'm going to say n equals 0, 1, 2, 3, so on and so forth. And then I've got a sub 0, so that initial value, so the amount that we're starting with. The amount that we're starting with is 200. So that's my recursive rule. Now, in order to write my function rule, remember, recursive rule requires that I can only answer that if I know the term before it. So if I want to know the 32nd term, or the 32nd month in this case, then I have to know the 31st month, and the 30th, and the 29th, and the 28th in order to get to the 32nd. The function rule is one where I can just plug in, if I want to know the 32nd month, I plug in 32 for some variable within my equation to get the amount that I'm going to have back. So what I'm going to go ahead and do with that one is I'm going to have my function rule would be a sub n, and that's equal to. And the way you're going to set up the function rule, it's always going to be doing the same thing. It's going to be a sub n equals, and then it's going to be the initial value, so in this case, 200, times my growth or decay rate, which we already discovered was 1.10, so that's going to be 1.10 to the n exponent. And then n equals 0, 1, 2, so on and so forth. So this is my function rule. Now I could take this equation that I have right here and plug something in for n and know exactly how much money I would have. So let's try that. For example, I could take that exact equation that we have right there, 200 times 1.10, and then I'm going to put in my exponent. Let's say I want to know how much I have after 9 months of savings. So I put that in, and that tells me right now that I have $471.59 saved if we go for 9 months, or I shouldn't say I, but Derek does. So you see how I can do that there. I didn't have to know how much money we had saved the first month, the second month, the third month, fourth, fifth, sixth, seventh, and 8th month in order to calculate out the 9th month. All right. Now, number 2, how long will it take Derek to save at least $2,000 for the down payment if the only additions to his savings account are his parents' interest payments? So again, he's not going to add anything else to the bank account, just that original $200 and then 10% interest that he's getting from his parents every month. And it's 10% on the new balance. It's not 10% on the 200. So he's not just going to get that $5 added every month. It's 10% of whatever is in the account each month. Okay, so it's not going to be going up linearly. That's why this is exponential. I probably should have said that earlier. Let's go ahead and look at this here. So if we have $2,000 and we want to know that's how much money he needs to have at the end. Well, let's kind of consider what we have here. There's no way I can use that information over here in this recursive rule, because that means in order to know the $2,000, I need to know how much money he's made the month before and all of that stuff in order to get there. I can use this function rule that I have over here. That $2,000 is what I need to set this function rule equal to. So I'm going to say I've got $2,000 is equal to 200 times 1.10 to the n power. Now, I'm not going to ask you to solve that, because in order to solve that, you'd have to sit here and do logarithms and all of that. Let me show you the easier way. All right, so what we would go ahead and do is I would put that information in here in my calculator. Let's see. Can't remember where it is on this one. Right here, table. So what I do is I hit the table button in this calculator. This is the little yellow calculators that we have in class, the TI-30XS. And I'm going to put this equation, the 200 times 1.10 to the n power. And since I have n written, I'm just going to tell you right here, this is your variable button right here above the store to the left of number 4. It's just an X. It doesn't have to be n specifically. It just means it needs to be a variable. That's all. And so now I've got this in here. And now I'm going to set up my table to start the correct way. Well, I want to start in 0. Okay. And so that means that that's what my n value is for starting. And then this step button is, if I go by ones, that means that the next input would be 1. Then the next input would be 2. Then the next would be 3. So if I was going up by 0.1, then it would be 0, then 0.1, 0.2, 0.3. So that's what we have here. So you're usually going to want to keep it as 1. So now I've got this, and now I can see that this would be how much money I would have each month as we're going. So we have 200, 220, 242, and then it's going to just kind of keep on going. So what we need to do is we need to see when this y, this output value here, equals the output value I wrote here, the 2,000. I need to know, when is this balance on the bank account going to equal 2,000? And I can see it's growing. You can see it's getting bigger and bigger as we're going down here. And it's going, and we're getting close. There we go. So at 24 months, we were not across the threshold of $2,000. We were still just short, about $30 short. But at month 25, we crossed over. So we have 25 months. We would have $2,000 saved. So we're going to say 25 months. Okay. In an effort to speed up the time needed to save $2,000, Derek decides to take on some jobs in his community. Suppose he commits to adding $50 per month to his savings, starting with the initial deposit from his parents. Fill in the table showing the amount of money Derek will have out over several months. So month 0 says we've got the $200, right? And then we're going to have that $200 times the 1.10 that we already had for that interest that his parents were going to pay. And then he is adding $50 each month to that. So we would go ahead, we put that in the calculator. So let's do that. So we would have the 200 times 1.10. And I should probably put that all in parentheses. I mean, it doesn't really matter, but 200 times 1.10. And then we're going to add the $50. Okay, so that gets me $270. All right, we'll go over here. $270. Okay, next one. So this next one, I'm going to start with the money that we have in the bank account right now, and that's 270. So I got 270. And then we're going to multiply that by the 1.10 because that's that 10% interest that his parents are going to pay him on the 270. And then he is going to add $50. So again, 270 times 1.10 plus 50. And that gets me 347. Okay, 347. All right, month 3. Month 3, I'm going to take the previous month, that 347. So we've got that 347, and his parents said, hey, we're going to give you 10% interest on that $347 that you have saved. And then he's going to add $50 to it. So we're going to do that. $347 times 1.10 plus 50. And that's going to get me 431.70. 431.70. And we would keep doing this all the way down. So let me go ahead and fill this in, and you can kind of do it on your own as well if you'd like to. So there's everything filled in. All right, so double check, make sure that you went ahead and you got all those numbers correctly. But as you can see, each and every single time, I'm taking the previous term and multiplying it by 1.10 and adding 50 every single time. So like here's 740.09. So the next one is 740.09 times 1.10 plus 50. So every single time we're just adding to it, okay? All right, so now it says make a scatter plot of the data that you generated in the table and compare the scatter plot to the function rule you found for question 1. How does adding $50 per month to Derek's savings change the way in which his money grows? So let's kind of create a scatter plot that we have of this data. Oh, that is not a straight line. Hold on. Okay, so scatter plot. Well, that's not straight. And of course, it won't let me erase. So there we go. So we'll just do that. So here we go. So the way that the money is going to go ahead and grow, we can see right here. Let's just start right here is 200. Okay. And this would be month 0. Both of them start at 200 and they increase. So what I'm going to do is I'm going to go ahead and I'm going to consider that I've got each one of these things right here. And actually, let me pull up the calculator so we can look at the table. And I will start this in a new video for the next part because my video is going to cut me off at 15 minutes. So we'll go ahead and finish this problem in the next video.